Hey, Patrick here, and today I'm going to show you how to build your own DIY SFX-100 shield. Those of you that either missed the group buy or just want to do it yourself, I'm going to walk you through all the steps. And so, yeah, let's go ahead and get started. All right, so let's start with downloading the files that we'll need to get the boards fabricated. And you can do that from my GitHub repository. I'll put the link for this in the description below. And what we want is inside the group by addition folder, there are the Gerber files right here. So this is everything we need to manufacture the boards. The zip file here has the actual CAD instructions for manufacturing the board, and then this Excel spreadsheet has all the parts that we need to solder to the board. So we'll get both of these files, just click download, and we'll also download this Excel spreadsheet. All right, so here's our downloaded files. We've got the Excel spreadsheet and this zip file with all the CAD stuff in it. If you open this up, you can see all the individual files that make up the different layers of the board that the fabrication shop will need. So no need to unzip that. We'll just leave it as a zip file, and we'll use that in the next step. Okay, so let's get the boards ordered. The company that I'm going to recommend is called JLC PCB, and this is a China-based fabrication shop, and I've had good luck with them. There are plenty of shops out there that you can use to have this kind of work done. I've used Osh Park in the past. They're local in the US, and frankly, they're more expensive and take longer to produce. So while I do use them occasionally, lately JLC PCB has been kind of my go-to. It's pretty hard to beat their costs, and their turnaround time is really quick. So I'll step you through the process of ordering a board from them. We're going to click on this calculate button and just click add your Gerber file, and then we're going to select that zip file we downloaded, and it's going to read the zip file, and in a moment it should pop up a little preview rendering of what it thinks the board looks like. And this is just based on all the individual layer files. And this is exactly what I would expect. You can see the motor connectors and all the silk screens and the copper traces and everything on there. So this is looking good. I can also see the text on here says I'm version 135, which is the one we want. And down here for all of these kind of specifics about the board, you can leave every single one of these things at the default. In fact, you probably should. And just going through these briefly, it's automatically detected that this is a 2-layer board, so that's good. The dimensions it has already filled out for us. The quantity was one of the downsides of this shop, is they'll produce a minimum of 5, which isn't actually too bad. I mean, the cost of their boards is so low. I mean, we're looking at $10.50 here, so for 5 of them. So it's a really good deal, and it'll actually cost more to ship it than it will to make the boards. So, and honestly, if you're new to soldering, it's probably good to have some extra boards so that you can practice. And anyway, I think it's good to have some spares, or you can build one for a friend or whatever. The PCB thickness 1.6 is the default, and we'll stick with that. The color, you can certainly change this, although green is their quickest turnaround. These other colors might take more time, but you can do that. And then all the rest of this stuff, we don't need to worry about. The defaults here are perfectly fine. Okay, so now the PCB is ordered, and let's get the parts ordered next. Open up the spreadsheet that we downloaded earlier, and inside you'll see links to all of the parts on DigiKey that we need and the number that we need. So if we click on this first one, this is our DB25 connector. We need 4 of these, so let's fill that out, add it to the cart, and there it is. Let's get 1 of these screw terminals and add that to the cart. Let's get 1 of these 10-position pin headers. And this 8-position, we need 2 of these. Let's put 2 of those in. And lastly, this 6-position pin header. You can honestly buy just a long cuttable pin header and cut them into the sizes that you need, but just for the purposes of having an accurate bill of materials. This works great. All right, so that's everything we need. We can close this, and once everything shows up in the mail, we can go back into the workshop, and I'll walk you through soldering all this stuff together. All right, so everything's ordered, and in a few days you will receive your boards from China, and they will look something like this. So let's take a look. And this is version 1.35. This is the same version that we had fabricated for the group buy. So that's what we're going to be building today, the same board that people in the group buy are getting. So aside from this PCB, you are also going to need a few other things. First of all, we'll want to have our Arduino. It's actually just helpful for doing the soldering, getting everything aligned well. We're going to need a couple of these header pieces that we ordered from DigiKey. So we've got this 10 pin, we have a couple of the 8 pins, and we have this 6 pin, and then we have the screw terminal, and of course the 4 DB25 connectors. So this is all the stuff we'll need to get started, and of course we'll want some solder, soldering iron, and I think that's it. So we can go ahead and get started. I think we'll probably start by putting these pin headers on, and the best way to do this is, I think, to actually put the pins into the Arduino and use those to kind of keep everything stable as you're doing the soldering. So let's move some of this stuff out of the way. And let's get the Arduino out of the box. All right, so here's the Arduino. And I think the best way to get these things aligned is to just go ahead and put these pins into the Arduino sockets, right where they are going to interface. All right, so these are all in the correct position now. So now we can take the circuit board and just line it up with those pins. And here we put this under the microscope so you can see a little bit better. You can see that those pins are now coming through the board and lining up with these holes here. Now, what I like to do is take a little bit of this solder off of the spool, just so it's not this big unwieldy thing. And that way we can sort of have a little length of solder that we can sort of work with a little more precision. So the first step, I'm going to take your iron. I have this iron set at 340C right now, which seems about right for this process. If your iron doesn't have a thermostat on it, it should be fine, or just set it to whatever the medium setting is. And you want to apply a little bit of pressure to the board so that it is sitting flat, and we're just going to tack down the first connector here. So I want to get a little bit of solder on the tip here, just so that it has some molten solder on there, and then we can press it up against the pin, and that'll kind of heat things up, and then just give it a little bit of solder, wait for it to heat up, and then come off, and there is what your solder joint should look like. So now that we've got that one tacked on, let's look at doing the opposite corner, which is going to be right here. So let's get that guy down as well. Remember to apply a little bit of pressure just to keep the board flat. Heat it up, give it some solder, and then come off. All right, so let's check those connections and just see what they look like. Because this is an area where you want to make sure that you're getting good, clean solder joints. So let me focus on this guy. So this is how they should look. They should be a little bit shiny, and they should have that kind of dome shape. And you want to see a good connection to the board, and just enough solder to kind of come up to the top of the pin there. So this looks like a good connection. Let's look at the other side here. That also looks like a good connection. So this is what we want to see on all of these. So now that these connections are tacked down, it's a lot easier to get the rest of the board soldered up. So I'm going to go ahead and just do a few more of these. I'll do a couple more under the microscope so that you can just kind of see the process. All right, so then we have a solder bridge that has happened here, and it's no big deal, but it's not what we want. So we just want to take the iron, come in here, and break the bridge. All right, so that's the first row. Let's just give them a quick look over here and make sure that they all look okay and that we don't have any solder bridges. Those look good. Those look good. All right, so let's head on over to the bottom side of the board and get the rest of these pins soldered in. All right, I think those are in pretty good shape. Let's just give them a once over here. Yep, those all look good. All right, so from here we can probably, let's see, we can probably take the Arduino off from here because we don't need it anymore. It was just there to kind of give us a nice stable surface for getting those pins soldered onto the PCB. So next up is the DB25 connectors. We should have 4 of these. Let me get these out. All right, so the DB25s go onto the top of the board, so the other side from the pins. And they'll only fit one way. So let's just get that going. So I think what I'll do here is, again, I may put all of these onto the board, even though they're gonna try to fall out when I turn this over. This is gonna give me a stable platform to work on if I get them all in here. So there's 2. And they do actually kind of snap in. I've got these little tabs in the back that They don't really snap in strongly, but they're enough to kind of give a nice alignment. All right, so let's kind of hold the connectors on as I turn it over and then set it down. And let's take a look at the microscope. You can see that those pins are all coming through the drill holes. Everything looks well aligned. And again, we're just applying a little bit of pressure just to keep the board flat, because I'm going to tack down each of these sockets. So let's start with this guy here. All right, and again, you just want to basically apply the heat to one side of the pin and then the solder to the other side, and then just let the heat from the pin melt the solder. And that'll make sure we're getting a nice clean connection. All right, I think I'm going to do the rest of these without the microscope, because that's mostly for your benefit and kind of makes it harder for me to do. So I think you kind of get the gist of it. So I will just finish up the rest of these, and we'll probably speed through this. All right, now you might notice that not all of these pins are connected to anything on the PCB, and that's okay. You don't actually have to solder every one of these pins, but do remember that there are connections on both sides. So even if you don't see a connection on the back, that doesn't mean that one of these pins isn't connected on the other side. So, and honestly, I think just for strength and durability, it's best to go ahead and solder all these pins on. So I'm going to finish up the rest of these pins. I'm also going to just take a look at these connections and make sure that they all look okay. Okay, here's a little section that we're going to want to clean up. I've got a little solder blob in there. And even though it looks like it's not causing a problem, we want to get that out of there. So let me see if I can just poke it out with a knife. There we go. You can just brush it off there. All right, so that looks good. Excellent. Okay, so all of the DB25s are now soldered on, and we're down to the final component, which is this e-stop connector. It's the little screw terminal, this guy right here. And the way that the case is currently designed for this thing is that all of the cables exit on the left side of the case. So even though this connector is over here on the right, and I used to have a design that had the outputs over there, for our purposes, I'm going to have the screw terminals facing to the left. If you want to do it the other way, it's totally fine. It won't make a difference. The polarity of this wiring doesn't make any difference. So this is the last piece that we're gonna wire in. So just turn it over here, and so this piece here, it's kind of loose, and it's not really a super great way to tack this down. All right, well, sometimes you'll have a component that just doesn't sit well on the board and is loose and hard to solder, so this stuff works great for that. And we will just kind of tape this component down. All right. So that looks reasonably tacked down. Okay. All right, let's take a look at that. Looks like the component is in good shape. Solder joints are reasonably clean. And yeah, there's a little bit of like flux and stuff on there that doesn't really matter. I tend to keep a little bottle of isopropyl alcohol around, which is useful for all kinds of stuff, but one thing it's good at is just kind of cleaning off boards. I like these Kimtech wipes for this kind of stuff, just designed for cleaning lenses and other just sort of delicate tasks. So get a little bit of isopropyl on here. Just come in and just clean that flux off. All right. And we can probably do that to the whole board if you want to get kind of some of that crud off of there. All right, well, if you've made it this far, congratulations. You should have a completed board now. Let's take a look. We've got the DB25 connectors, we've got our pin headers, we've got the e-stop. This thing is ready to attach to our Arduino. Like so. And yeah, actually this little piece down here is, we're not gonna use this for the enclosure that is designed to go with this, so we don't need this anymore. And yeah, this is it. This is the SFX-100 control board and the wiring shield. All right, so the next thing that we're gonna do is get the enclosure files downloaded and get those ready to print on the 3D printer. So I'll see you in the next video.